Hey Pre-Calc. Today we're going to be talking about periodic functions and how they relate to rides like Ferris wheels. So we're going to talk about how we can graph them and their movement and their waves and how they look like sine and cosine graphs. But first, let's remind ourselves how we even draw them. So let's look at this one. It wants us to draw a periodic function. Let's assume that it wants us to draw a positive sine graph, even though it doesn't say that. So we're going to do a positive sine graph, and let's talk about our amplitude, period, and midline. We want to start with our midline of 1. So I'm going to go ahead and draw in a midline of 1. Something like that. And it says it has an amplitude of 3, so that means we're going to go up 3 from the midline, so that puts us at 4. Highest point is 4. And then we're going to go down 3 from our midline, 1, 2, 3, so it puts us at -2. So 4 is our highest, -2 is our lowest. And it says that it ends at a period of 6, so that means it's got to go all the way to 6. So how many points do we need? Well, we know it's going to start at 0. We assume that, unless it tells us otherwise, unless it has a phase shift. So we know that halfway through, we're going to be at 3, right? Because 6 divided by 2 is 3. So then, what would it be halfway to 1 and 3? Well, hopefully everybody would say 1.5. And then halfway between 3 and 6 is 4.5. So those are kind of like our intervals. Those are the points that we're looking at. And how do we know that if we did not just use logic? So what's the math behind it? So we typically, to find our increments, do period divided by 4, right? That's how we find our increments every single time. So if we know our period is 6, that's how long it takes to go through one wave, divided by 4, that gives us 3/2, which is equal to 1.5. So that's all we're doing. We're adding 1.5 each time. So that might make a little bit more sense to you guys than the logic behind, if you have to have 5 points and 0 to 6 and then dividing them up equally. Okay, so we assume that it's going to be a sine graph, so that means, and positive, so that means we have to start at our midline. Sine starts at your midline. And if it's positive, that means at 1.5, we're going to be at our highest, at 4. And then what about at 3? We're going to be back at our midline. 4.5, where are we going to be? At our min. And then 6, we're going to be back at our midline. And so now we just connect the dots. And we're done. So that kind of just reminds our brains of how we graph these periodic functions. Okay, flip over. Okay, so if I was there, I would show you some of these videos and then we would look. It takes a long time. So I want us to get through to maybe working on some of our homework problems. So you can look at these on your own if you want to. They're just different types of Ferris wheels and kind of gives you an idea of what they look like. But I'm sure everybody has been on a Ferris wheel at least once in their life. All right, here's some things about the London Eye, probably the most famous Ferris wheel that there is, at least at right now. I know Singapore has a big one, and but the London Eye is kind of the most famous. So you guys can read through that if you want to, but I'm going to save time, and I'm going to go into the actual problem. So let's say that we want to graph our journey. Graph our journey if we were to ride the London Eye, okay? So the height of the London Eye is 135 meters. So I'm going to just quickly graph maybe what it would look like on a Ferris wheel. So if we were looking on this, let's do feet since we're used to feet. We're gonna, so from top to bottom, that is 442 feet. So we're going to assume that it starts at the very bottom, right? And we're going to assume that it's going to be, what does it say? I guess we're going to assume that it starts at 0 feet, right? And then at the tip top, it's going to be 442 feet. Now, it's not always going to start at 0. Sometimes you're going to see that you might have a platform that you have to walk up to get on to the ride or the Ferris wheel. But right now, we're going to assume that if it doesn't tell us there's a platform, then it doesn't tell us where to get on, that we're going to start at 0. And then we're going to figure out how to ride it. Now, depending on the Ferris wheel, I'm assuming that it's going to go up first. Every Ferris wheel that I have been on as a kid, I didn't go backwards. My back wasn't going backwards. I was always going forwards, and then at the top, then I would go back down. But maybe that's not true, but we're going to assume that for now. So if I were to ride this thing, and it says that, does it even tell us how long it takes to go around it? Oh, it does in our other slide. So if you go back over here, it says that each rotation takes about 30 minutes. So we're going to assume that it takes 30 minutes to go around this thing. And it goes slow enough so that people can step on and off without the wheel having to stop. So if we start at the very bottom, we get on at 0 minutes. Does everybody agree? And if we go all the way around, it's going to take us 30 minutes to get back to where we started. Okay, everybody agree? So what does that mean for us? Well, if we were going to graph this, that means this is going to be what type of graph? If we get on at 0, and then we go all the way around and get back off at 30 minutes, I'm hoping that you're going to see that you're starting at the bottom, so you're not starting at your midline. So if you're not starting at your midline, you're going to have a cosine graph. But let's assume that we don't know that yet. Okay, so if I get to the very top of the Ferris wheel right here, if it takes 30 minutes to go around the whole thing, how long does it take to get to the very top? Well, hopefully you would say it takes half the amount of time. So we're at 15 minutes. Okay, so then let's look at, all right, if I had to get to right here, the middle, to get halfway to the half to the top, what would it be? Well, that would be 7.5 minutes. And to get to the other side, so we're kind of hitting at you're hitting at the bottom, then you're hitting at the midway to the half, then you're getting up to the very top and then back down to the halfway to the bottom. So that would take you 25 minutes to get to, and then back around to 30. And that's where I get my 5 points that I have to graph. 0, 7.5, 15, 22.5, and 30. So guess what? Those are your increments. Because if I did 30 divided by 4, because 30 is your period, you would get 7.5 minutes. So those are your increments. So if we had to graph this, we start at 0. We know it's going to take 30 minutes to get through the whole ride. Halfway up, we're at 15. And remember, our increments are 7.5, so we know 0 plus 7.5, 7.5. Add another 7.5, you get 15. And another 7.5, you get 22.5. And another 7.5, you get 30. So those are our 5 points. So now, we've got to go from 0 all the way up to 442 feet. So what's halfway between that? So what's halfway between 4 divided by 2? Well, you would get what? 2, 2, and 1. So that would be 221 feet is halfway. And why do we care about halfway? Well, we care about halfway because these points right here. So you're really looking for your radius of your Ferris wheel. So to get there, that's 221 feet is your radius. Okay, so hopefully this makes sense. If anybody is confused right now and somebody else is getting it, then I need you to stop and like pause the video real quick and then see if you can help each other. If not, I'm going to keep going. Okay, so at 0, so now it's kind of like order periods. At 0, we're at 0, right? We're getting on the Ferris wheel. At 7.5 minutes, we're at our radius. We're halfway up. We're at 221 feet. Okay, at 15 minutes, we're all the way to the top. That doesn't look like. Okay, so all the way to the top at 442 feet. Okay, then it might be easier if we go ahead and draw on our midline, because halfway up is going to be our midline. And then at 22.5 minutes, we're back halfway up. And then at 30, we're back at 0 and we're getting off. So what kind of graph is this? What kind of graph is this? Hopefully you would say this is a negative cosine graph because it starts at the very bottom and then goes up. So it's a negative cosine. And tomorrow we're going to be learning how, if we're given this, how do we write the equation? But today we're just graphing. So let's map it real quick. So what do we know our midline is? Well, our midline is y equals 221. What is your amplitude? Remember, your amplitude is going to be your radius because it's halfway up. Or you can do your midline minus your max. That's going to put you at 221 feet. And what is your period? Well, it takes 30 minutes to go through one graph. Kennedy's in here. Yes, you can have that. Okay. All right. Okay, so that is our first one. Okay, let's look at the second one. Okay, so it says graph the height of the function, time, and then the period, amplitude, and midline. Okay, so a Ferris wheel is 70 feet in diameter and is boarded from a platform. So this is what I'm talking about. So it gives you a platform of 10 feet in the air. The 6 o'clock position on the Ferris wheel is level with the loading platform. The wheel completes one full revolution every 12 minutes. You make 2 full revolutions. Okay, so let's look at that one. All right, here we go. So there's lots going on here. Let's look and see what it would look like first. So I'm going to go ahead and draw my Ferris wheel so we can get an idea of what it looks like. But this time, before I do that, we're having to load this thing 10 feet in the air. So we're having a platform of 10 feet in the air. So we have to do that before we even get on. Does everybody see that? And so then we can draw our circle. So it still seems like we're getting on at 0 because it doesn't tell us otherwise. It doesn't say your platform is 10 feet in the air or after, like, it doesn't say like it's 10 feet up from the Ferris wheel or something. And it will do that later on, and I'll show you what that means when we get to a problem like that. But it says the 6 o'clock position, so that's down here. If you're looking at your clock, that's a 6 o'clock position. You are level with a loading platform. Okay, so the wheel completes one full revolution every 12 minutes. So let's go ahead and figure out what our period's going to be. So if we know it takes 12 minutes, so that's our period. So let's find out our intervals is really what we're looking for. So our interval is going to be every 3 minutes. So that means when we get halfway up, it's going to be 3 minutes. We get all the way to the top, add another 3 minutes. That's going to be 6. Halfway back around is going to be 9. And then to make a complete circle, we're back at 12. Okay, so does everybody see that? The only thing that is different kind of here is that it says